what's the function? If I have W and V, and you say that I map from V to W, write this error. Just to let you know some advanced thing. Sometimes people write this. This means the mapping is not unique. This is actually for this kind of thing. This is not a function. Because 1x can map to 2y, then you write this. But if you only have 1x go to 1y, you write one error. And there are even other crazy simple like this. Okay, I'm not going to talk about it. I will talk about it when we see it. Okay. Then what is the definition? It means 1v in big V map to 1w in W. And this is the way we write. This means the domain of F is this set V. The codomain is W. Then what about if we want to write a specific element? We write this. This is the y equal fx you learned in high school. So this means what? This means we have a way to connect two stuff from V to W. You can also write this. So for example, I want to write y equal x squared. You can write this. You can also write this. You can also write this. Or you can also write x, this to x squared. So this arrow have a bar. And then now this funny picture that looks like a Mickey Mouse is a set, have a name called graph. Graph means all the x and y in the R. What is this? X coordinate, y coordinate, Mickey Mouse. Okay, that's why I draw Mickey Mouse. This is what? This picture is when I zoom this Mickey out to infinity, then I don't see it, I see this. And this action is already the very beginning of what is infinitely small, infinitely big calculus, but later, okay? So this is Mickey Mouse, okay? This is graph. You can spell it as graph, or you can spell it as GRA, or you can just say G, doesn't matter. That's why I write this symbol, okay? This thing is just a set. And then what about range? Range is again defined as a set. Some people write a square bracket X, some people spell it out, and you have this set. Remember this Mickey Mouse, this is range. This whole big chunk of thing is codomain. Because we cannot get negative value, so the range is all the positive and zero, okay? That's the meaning. And then again, notation, some people write square bracket, some people write the whole word, some people spell image, and some people write IM. IM can confuse with imaginary number in complex numbers. These are all confusing. So therefore, I will just write the set. Just write the set. And now, after we talk about all this, how do you show two functions are equal? Well, if you have two functions to be equal, first, they need to have the same input, right? If this map from Earth, this map from Mars, they are not equal. Secondly, they need to have the same output. So these codomain are the same. If this is real number, this is complex number, they are not the same, okay? And then what? They are equal if and only if, okay, let's go with if only if and only if, and then the and, right? Only if, that means from here I can go to here, and from here I can go to here. So if fx give you gx, and if gx give you fx for all x, this is the definition. In other words, means they have the same set like this. So you have two ways to prove two functions are the same. The first way is all the fx give you the corresponding gx, and all the gx give you corresponding fx. This is like the mathematical way. But you can also have a set way. You treat this as a set. It's a what? It's an ordered up pair. That means it's a set, right? But this set inside the element, each element have two stuff. One is the input, one is output. And you prove that for all the pair, the two sets are the same. That means this set is a subset for the G1, and the G1 is a subset of this guy, then the two sets are the same. And last time I talked about this, so now you should understand why they are not the same. This guy, input set is all the real number except 4. This guy, the set is all the real number except 2 and 4. But for two functions are the same, these two red sets have to be the same. It's already not the same in the first step, so done. We don't need to talk about it. And lastly, you can also do this. Fx equals gx, right? I can put 2 here, right? I cannot put 2 here. They are the same. If you do this, this is different. A person, after the head is chopped off, and the previous person is two different persons. So, not the same. Again, I use crazy example because that's strong impression and you remember it. Okay, again, don't chop other people's head. We are not French, so no problem. Okay, so now these two are the same. How do you show they are the same? What is absolute value? Absolute value is what? X, if x larger than 0, negative x is x smaller than 0, right? Then now I have square. It's the same as this, right? Negative square is positive, so they are the same. So therefore, absolute value square is that square. Then now I have what? This become x power 3, x power 2. High school. That's why. This is the algebraic proof proving that they're the same. But then, can you do the same thing here? No, you can't. So how do you prove these two the same? You have to use other technique. For example, how do you prove f1 and f2 are the same? You use differentiation. How do you prove F1 and F3 are the same? First of all, you can assume they are the same by definition because this is called Euler formula, or you use complex number to show that they are the same. We don't touch this in this course. Okay, F1 and F4 is very complicated. You don't know what the heck is going on, so no. How do you show F1 and F are the same? You know how to do calculus, right? Then you know integration, this gives you sine x, therefore it's the same. So to show these two are the same, you do differentiation. To show these two are the same, you do complex number thing, and you show these two are the same, integration. Later, you will learn F2 and F5. F3, I will touch a little bit. And then these two things are the same. Yeah, you have a function that looks like this, is something that looks like this. So it's basically on, off, on, off, on, off. This function, you have no way to write it down as f(x squared, x squared root, something like that. You have no way to write down, so you have to write something like this, like a split function. So for all integer n, if the x is within this range, then it's a 1. If not, then it is negative 1. So basically it's like what? I have a 2 pi period, and then 2 pi period, and then 2 pi period, and 2 pi period. Now this is a function. This is also a function. These two functions, I can tell you they are the same thing. That means what? And again, absolute value have two forms. This is absolute value. This is also absolute value. And absolute value, I just show you, right? Absolute value is just split function. It's the easiest split function. And the following here also a function. This guy is also a function. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, right? You can also write a split function. What is this? It's saying that, okay, suppose I want to find what is 7 factorial. I put inside 7 larger than 1, right? Go to this case, so it will be 6 factorial. Oh, I don't know what is, okay, sorry, I made a mistake. Okay, 7 times 6 factorial. Oh no, I don't know what is this guy. N is 6, go inside. N is larger than 1, right? Okay, so it is 6, 5 factorial. Okay, I don't know what is this. Oh, come back. 5 larger than 1. This case, so 7, 6, 5, 4 factorial. In the end, you get this. Okay? And this actually has something to do with code programming. This is called recursion. You call the previous version of yourself until the starting point. So this is also a function. Recursion is also a function. Composition of function, I talk about it, just a relationship. And then, now, new stuff. Restriction basically means I have x to y, right? Now, I don't want anything outside my a. I just want this. So then I do restriction. You may wonder, who do this? Here's an example. My fx is log x, and my f is r to r. But everybody know, if x is negative, this guy is error. So I restrict myself to what? All the positive value. And actually not positive, it's strictly positive. You cannot even have 0. So I will have r plus plus. This means I only have x larger than 0. I don't even allow this. Okay, no. And this, no. So these two are no way. This is the idea. So this is restriction. Because if x is negative, error. For this class, x is negative is error. I tell you what happens if x is negative. If x is negative or is a complex number, we will have 2 pi ni plus log principal z. That means you have a complex number, take the magnitude, and then this is positive. You can take log, but now you have to add a complex part. In other words, if your number is negative, if you take log, you have more than one number because this n can be any number. So this is not a function. This is a relationship. You have one x, but you have more than one output. This is some crazy thing you learn later, okay? And then let's recall the picture, the Mickey Mouse, okay? Mickey Mouse have no copyright. I can say shit about it now, okay? So what is the function? Function is this. It's just a relationship. What's the relationship? Some special Cartesian product. What's Cartesian product? Some set. What is set? Some sentence is true. What's true? Logic. That's it. Then, now for function, here are 3 important things called injective, surjective, bijective, which is very important. And later on, when we talk about what is infinity, we need this guy.